Welcome back to the channel. In the last video, we talked about achieving high availability in systems. Today, we are going to explore another crucial concept in system design, reliability. Reliability ensures that your system consistently performs without failure over time. In this video, we'll cover strategies and best practices to improve system reliability. Let's dive into it. First, what is system reliability? Reliability is the ability of a system to function consistently and correctly over time, even under stress or in the face of occasional failures. A reliable system delivers correct responses to requests and recovers from any failures as quickly as possible. For example, a reliable payment system ensures that every transaction is processed accurately, even when there is a heavy load on the system. In contrast, unreliable system might drop transactions or process them incorrectly. So, now we need to talk about factors that affecting reliability. There are several factors can impact the system reliability. We can talk about 4 of them right now. First, which is the hardware failure, like physical servers or network components can fail. Second, software bugs. Issues in the code base can cause unpredictable behavior. 3, human error. Mistakes in deployment, configuration, or maintenance. 4, external dependencies. Third-party services or APIs your system relies on can introduce failures. Okay. We need to think about strategies for improving system reliability. And we could start first. The first step is improving reliability is ensuring that your system is thoroughly tested. There are several levels of testing you can implement. There are unit tests, which are test individual components of the systems in isolation. There is integration tests, which are ensuring that different parts of the system work well together. There is load testing, which simulates heavy usage to see how the system performs under stress. It's called also performance testing. There is end-to-end testing. It simulates a real-world scenario to validate that the entire system works as expected. For example, in payment system, load testing could simulate thousands of users making transactions at once to see how the system handles the load. So, to ensure reliability, you need to constantly monitor your system and set up real-time alerts to catch issues early. Tools like Datalog and Grafana can monitor system performance, resource usage, and user activity. For example, you can set up alerts for CPU usage, memory consumption, or error rates. If any of these metrics exceeded a certain threshold, your monitoring tool will alert you to investigate and resolve the issue before it impacts users. No system is perfect and errors will happen. What's important is how your system recovers from those errors. To improve reliability, implementing strategies for error tolerance and recovery. First, we should work with graceful degradation. If a part of your system fails, allow the rest of the system to continue functioning. For example, if a payment processor is down, The shopping cart and browsing features should still work. Second, retries and backoffs. For transit errors like a failed network request, implement a retries with a backoff strategy where the system waits before retrying the requests. So, one way to improve system reliability is through redundancy and replication. By duplicating critical components like databases or services, you ensure that if one component fails, another can take over without disrupting the system. For example, many databases offer replication where data is stored on multiple servers. If the primary database fails, the system can switch to a replica, ensuring no data loss and keeping the service operational. Okay, let's talk about real world example. So let's talk about real world example. A banking system. Here is how you would improve the reliability. First, load testing. You should ensure that the system can handle high traffic during peak hours. Second, monitoring and alerts. Allow engineers to catch issues like failed transactions before they escalate. Error recovery techniques ensure that if a transaction fails, the system retries it automatically, and last, the replication of the database ensures that even if one server fails, no data is lost and transactions can still process. Okay, let's talk about reliable metrics. When measuring reliability, there are few key metrics we should focus on. First, the mean time between failures. Uh, this is the average time between system failures. The higher this value, the more reliable the system is. Second, mean time to repair. The average time it takes to recover from a failure. A lower MTTR means faster recovery and higher reliability. Lastly, uptime percentage. A key metric that measures the amount of time a system is available and functioning correctly, while availability is often the focus here. Reliability plays a critical role in keeping uptime high. Okay. So, finally, reliability isn't just about the technical aspects, it's also about building culture of reliability within your team. This means encouraging mortem analysis after failure to identify the root causes, prioritizing testing and code reviews to catch issues early, promoting continuous improvement by learning from past failures and refining processes. At companies like Amazon and Netflix, reliability is top priority, and teams are structured around ensuring that systems can perform under any circumstances. Any circumstances. So, to wrap up, improving system reliability involves first a thorough testing to ensure the system works under different conditions. Second, monitoring and real-time alerts to catch issues early. Third, error recovery and tolerance to handle failures gracefully. Fourth, redundancy and replication to prevent data loss and service disruption. In the next video, we'll talk about how to balance availability and reliability and discuss trade-offs between the two. If you found this video helpful, make sure to give it a thumbs up and subscribe and hit the notification bell to stay updated on new videos. See you in the next video.